In this video, I will be explaining an example of a problem in which we have a general annuity. Let's see the problem. Scott has saved $1,200 every 6 months in a saving account, earning 5.25% compounded quarterly for the last 6 years. He plans to leave the accumulated saving for 8 years in the saving account at the same rate of interest. How much will Scott have in total in his saving account? So at the end of these 14 years, because we have 6 years at the beginning in which he was depositing this $1,200, and then he lived this saving for 8 years more. So there are 14 years in total, and we want to know how much will have Scott at the end of these 14 years. And second, we want to know how much of this will be interest. So let's solve first this first part. How much will Scott have in total in his saving account? So we need to think in this annuity that is something like this. So we have been making deposit of $1,200 during 6 years. But after these 6 years, Scott lived this money for 8 years more. And we want to know how much will be here at the end. So my idea to solve this problem will be compute the future value of this annuity, because this is an ordinary annuity, ordinary general annuity. So what we are going to do is find the value at the moment of the last payment. So how much will be exactly immediately after this payment. And after we compute this value will be the present value of the second period. And the second period is not an annuity, it's just a moment when we are just using compound interest. Okay, let's work first in this annuity. So let's compute the future value of this annuity. So we know that the formula of future value is this. So in the future we need R, we need N, and we need I. So R is given because it's $1,200. So let's take note of this. The payment is $1,200. We also know that these payments are making every 6 months. So there are 2 payments per year. So I'm going to write that K equal to. Remember that I represent the number of payments per year with the letter K. So K, it will be equal to. And then this K is 2, we know immediately the total number of payments because that happened for 6 years. So N will be just 6 times 2, so equal 12. So we have the number of payments. And now let's think in the interest because we need to compute this I. So we have already R of the formula, we have N, and we need to compute this I. To compute this I, first we need the rate of interest. This rate of interest is 5.25. So I'm going to get the nominal rate of interest equal 5.25. And this is compounded 4 times per year because it's compounded quarterly. I read here that it's compounded quarterly, so it means that M equal 4. So R equal 5.25%, M equal 4. This is the rate of interest compounded quarterly, but we need to find, or we need to use a nominal rate of interest compounded semi-annually. So we need to find the equivalent rate of interest compounded semi-annually. And I know a formula for doing that. Any time that M and K are different, so the number of payments per year is different to the number of conversion periods per year, we need to find the I in this way. So this is the formula I'm going to be using for I in these cases. Yeah? So will be R 0.0525, M equal 4, but I need to use this K that is 2. So I make a substitution, and this is the value I found. So this, after making the substitution, this 4 appears here at the denominator, but in the exponent appears at the numerator. The 2 at the denominator is the number of payment periods per year. It will be 2. So use your calculator to compute this I. So I use it, and I found that the I is 0.02642265. This is the number that will be here. Anytime that we have a general annuity, the I must be computed in this way. To use the formula of the future value of the annuity, or whatever formula of the annuity, the I in a general annuity must be computed in this way. Okay, now that you have this, let's make a substitution. R equal 1200, I is the number that we have just found, and N equal 12. So I found this, I make a substitution, use a calculator, and I already used the calculator, and I found that this is 16,688.39. So this is the amount that Scott have at this point here, at the end of the annuity. So this is the amount. This amount is the present value of the next period. The future value of any period is actually the present value of the next period. So this 1688.39 is going to be used as a present value for the next period. So let's start with the second period to get the future value here. This, what we have here is not an annuity, it's just compound interest. There are no payments here. So let's compute then the future value of this. So this is the present value, and we want to compute the future value of this 8 years later. So for finding the value of this account 8 years later, the present value will be 16,688.39. This is the present value. The rate of interest is 5.25, so I can try 5.25%. And M, the number of conversion periods per year, will be M equal 4. Then the I, in this case, we use this R and this M, the I will be 5.25% divided by 4. So remember the formula of future value. We can also compute the total number of conversion periods. The total number of conversion periods will be 4 times 8, 32. So let's type it here. The number of conversion period will be 8 times 4, 32. We can substitute everything in the formula. So the formula of future value of a compound interest problem is this. Yes? Future value equal the present value 1 plus I to the power n. This present value is this 16,608.39. The I is just the nominal rate of interest divided by how many conversion periods per year, 4. So it will be then 16,688.39, that is the present value, open bracket, 1 plus 0.025 divided by 4 to the power, and the power will be n, that is 32. To the power 32. Okay, so make a substitution. I found this number, 25,329.78. This is the amount that Scott have at the end. So this is the first question. How much will Scott have in total in his saving account? Scott will have 25,329.78 in his saving account after the 14 years period. Okay, so this is the amount after 14 years period. And what about the second question? How much will be interest? If we want to know how much will be interest, yeah, so the second part, it will be the future value minus the contribution. So everything that Scott have at the end minus his contribution during these 6 years. During his 6 years, he contributed 12 times 1,200. So we have then that the interest will be the last value minus the contribution, or S, 25,329.78, minus 12 times, this is the number of payments. Actually, this N here, this different than this N, this is N is the conversion period, so be careful. So, but this is actually the payments that he has made. So in this case will be 12 payments of 1,200. So make this, and you found that the total interest earned by Scott during these 14 years was 10,929.78. So the amount of interest included in the future value is 10,929.78. And with this, I finish this problem. I hope you have found it useful. Thank you.